Alrighty, welcome to lesson 12 and 13. In lesson 12 and 13, we're going to further talk more about understanding exponential graphs, and we're going to take it a bit further with generalizing our relationship between our initial value and our growth factor. So let's study and compare equations, graphs of exponential functions. And the first part is a bit of a review question. Jada receives a gift of $180. In the first week, she spends a third of the gift money. She continues spending a third of what's left each week thereafter. Which equation best represents the amount of gift money in dollars she has after G weeks? I forgot to add the G in there. Please explain your reasoning once you make your decision. So I want you to tell me between the four inequalities, functions, my bad. Between the four exponential functions, I want you to tell me which exponential function represents this situation. Remember to go back to lesson 4 and 5. We're talking about what is remaining that she is spending every time, not how much she's spending. She's spending a third. So to yourself, if you need to draw yourself a little diagram, figure out how much is remaining. In the next part of our activity, each of the following functions, f, g, and h, represent the amount of money in a bank account in dollars as a function of time x in years. They are each written in the form m of x is equal to a times b to the power of x. I'm going to show you the graphs here, but I'm also going to post the link in your Google Classroom. Use the link in the Google Classroom to graph each function on the same coordinate plane. I want you to explain how the value of b changes the graph. So here is our first example. So here are our four functions. We have three functions that represent exponential growth and one that represents exponential decay. I want you to compare your graphs. So when b is greater than 1, compare the blue, the red, and the purple. When b is greater than 1, how does the value of b, how does my growth factor affect the graph? How is blue, red, and purple different from each other? And if you want to take a moment and kind of think about how they're increasing, make a table for yourself. That might be an option too. When b is between 0 and 1, we have exponential decay. So I want you to tell me what happens as our function increases. As our function increases, what happens to my value? What happens to my output here? So you're going to do the same with your equations defining p, q, and r. They're also written in the form m of x is equal to a times b to the power of x. P of x is equal to 100 times 4 to the power of x. Q of x is equal to 40 times 4 to the power of x. And r of x is equal to 100 times 4 to the power of x. As you will see here, your initial value changes, but your growth factor does not. And so in this part, you will see that your initial value is changing and your growth factor does not. So how does that affect your actual graph? I want you to tell me what is changing here. I want you to use the vocabulary that we've been using over the past couple of days. So I will post both of these links in the Google Classroom so you can kind of play around with it as well, and you can add as many functions as you need. So suppose you're presented with four functions m, n, p, and q that describe the amount of money in dollars in a bank account as a function of time x in years. If the account is yours and the money and more money is better, which function would you choose and why? So I want you to match each equation with a graph. Be prepared to explain your reasoning. Functions f and g are defined by these two equations. And so your first step is I want you to match each of your graphs. And one thing that might be helpful here is kind of make a table for yourself. Compare what is happening in each of these functions. See which one do you think would be decreasing faster, which one would you be decreasing slower. My only hint to you is that remember that the decay function represents what is remaining. So they are saving 1/4, they are saving 3/4, they are saving 1/2, they are saving 7/8. So I want you to think about that as you're matching your two graphs together. Function f and g are defined by these two equations. F of x is equal to 1,000 times 1 over 10 to the power of x, and g of x is equal to 1,000 times 9 to the power of x, 9 over 10 to the power of x. Which function is decaying more quickly? I suggest making a little table to help yourself out as well. And so let's go through two examples. Remember, the 1/4 is what is remaining after each year. That means 1/4 of the bank account remains each year. On the other hand, this tells me 7/8 of the bank account remains each year. So what to think about that like logically for a second. If your bank account, if you're telling me that only 1/4 of the bank account remains each year, is that decaying faster or slower than as if I told you 7/8 of your bank account it remains each year? So tell me which two functions does that tell you? And then you'll be able to kind of piece out each of the remaining functions as well. Our last activity is our value of a computer. Here's a graph representing exponential function f. The function f gives the value of a computer in dollars as a function of time x measured in years since the time of purchase. Based on the graph, what can you say about the following questions here? So you should know the purchase price of the computer. I want you to tell me how it's decaying over time. How is the value of a computer changing each year? This is a little tricky. This is the first time we've had a value that's not constant, right? We used to go from 0 to 1 to 2, but they only gave you your initial value and your value after 2 years. And so the question is, what is the value after 1 year? What is my decay factor here? Right, so every 2 years it decreases by what value? A factor of what? So we can tell it is a factor of 1/4 if I divide the 100 by 400. So I know that but every 2 years it's decaying by 1/4. But that's not quite helpful yet for us because I want to figure out what's happening every year. And so what that's telling me is I need to take a number, multiply it by itself to give me 1/4 because it's decreasing by 1/4 every 2 years. And so I know that 1/2 times 1/2 is going to give me 1/4. And so that means my decay factor every year is going to be 1/2. So I can even try that out, right? After 1 year, the value of the computer is 400 times 1/2 is 200. 200 times 1/2 is 100. And that's exactly what I need for year 2. You can always check your answer when it comes to these questions here. And so if you're not sure if you did your decay factor correctly, that's something you can always check as you're going through. For letter D, make sure you give me a full sentence. After 1 year, the value of the computer is blank, and I just gave it to you earlier in the video. When you're creating your function, I'm reminding you once again, f of x is equal to a times b to the power of x. A is your initial value, b is your growth factor. So you are going to do that for number 2 as well, right? And so practice exactly what we are going through for 2 of those functions, practice exactly what I talked about in number 1. Last but not least, you are going to reflect on what the function is for both, and our 2 learning targets for today. You can describe the effect of changing a and b on a graph that represents our function here. I can use the equations and graphs to compare exponential functions. This wraps up everything before the mid-unit assessment, so I look forward to seeing you after the mid-unit.